All right, let's look again at volume and at slicing three-dimensional shapes. So first lesson is slicing 3D shapes. So we are slicing things that are parallel to the base, and we are slicing things that are perpendicular to the base. So what I think is when I'm cutting something parallel to the base, it should have the same shape as the base. Versus when I'm cutting something perpendicular or that vertical cut, it should be the shape of that side, right? So parallel is going to be that base side, perpendicular is going to be the lateral side there. So let's look at this. When I cut this shape, parallel to the base, what is my base shape? Well, for this, I have a square, or rectangle would work too. Versus the perpendicular cut, I'm going to look at that lateral, the shape on the side here, and that is also a square because we have a cube, so they're all the same. Let's look at number 2. The parallel cut, I'm slicing this way. What is that shape on the bottom there? That is a triangle. Versus my perpendicular cut, what shape is on the side here? We have a rectangle. Number 3, our parallel cut, I'm slicing it through here. What is that base shape on the bottom? It has 1, 2, 3, 4, 5 sides. That is a pentagon. Our vertical perpendicular cut, the shape that is on the lateral side, and you can use any of those sides to look at. We have rectangles. Okay, number 4, I'm slicing it parallel. The shape that's on the base here is a square. It could be a rectangle. This one looks like it's a square. Either would be accepted. Versus that vertical cut. What shape is on the side here? We have a triangle. Number 5, if I'm slicing it parallel, my shape, it's a little small, a little harder to see here, is a triangle. Our vertical cut, the shape that I see on the side, either I see this one on the front here or on the left side, is also a triangle. And then our last shape, cutting it parallel. The base that we have here is a circle. So when we cut it, it's just going to be a smaller circle, but it still would be a circle. And our vertical cut, it's a little bit hard to imagine, but if you kind of look here, it's not necessarily perfect looking, because I can't divide it perfectly here, but it looks like a triangle, and it would be a triangle. So that's a quick review of slicing three-dimensional shapes. Let's look at volume. So we're going to mix both volume lessons, 2 and 3. two formulas we need to remember. We have prisms where the volume is equal to the area of the base times the height, and pyramids, those come to a point. The difference is you're still going to do the area of the base times the height, but that big difference here is that you are going to divide by 3. So remember, prisms have 2 bases, pyramids have 1 base, and they come to a point on the top. So the side opposite the base is a point. So let's first decide what type of shape it is. Remembering that your base doesn't necessarily mean bottom, okay? So like when you're looking at this shape right here, okay? I know this is a triangular prism. It's got a triangle on the top and the bottom that are parallel. Just because I flip it on its side doesn't mean it changed its shape. It's just that it's oriented a little bit different. Now our bases are in the front and back versus the bases being on the top and bottom. Okay. So looking at number 7, I'm going to highlight my triangle base that I see right here. And I see another triangle back there. So that tells me there are 2 triangle bases, and the height or the depth that is connecting those 2 is right here. So since I have a triangle base, when I'm plugging in my formula, I'm doing this base, which the base and height of our base of the prism is 9 and 12. So we're going to do 9 times 12. It's a triangle, so divide it by 2. 9 times 12 is 108. Divided by 2 is equal to 54. So the area of our base is 54. For our volume, we are going to take this area of 54, multiply it by the height of the prism, which is the length that connects the 2 bases to each other. So times 16, and don't forget, actually, nope, that's it. We're doing the area of the base times the height here. When I plug that into my calculator, 54 times 16, we get a volume of 864 feet cubed. And I forgot to circle up here, this was a prism because it had the 2 bases. Number 8. Here, I automatically see this point right here, which kind of clues me that it's a pyramid, okay? And I only see 1 base here on the bottom, which looks like a square. It could be a rectangle. We'll have to look at the dimensions, okay? So since it has 1 base and it comes to a point, it is a pyramid. So we are using volume equals area of the base times the height divided by 3. The height, we don't want this slanted height. We want the height that is perpendicular to the base, which is this measure right here, which is, according to this, 3. Okay? So, no matter what, I always need to find my area of my base. For my base, it is a square or a rectangle. The dimensions are 5 times 5. So that tells me the area of my base is 25. So now for my volume, I'm going to take the area of my base, which was 25. I'm going to multiply it by the height of the prism. Again, this slant height is not the height of the prism. This perpendicular height is 3. And then remembering, for pyramids, we don't just do the area of the base times the height, we divide by 3. So you might realize those 3's are going to cancel, but if not, plug it into your calculator. 25 times 3 is 75. 75 divided by 3 is 25 inches cubed for the volume. All right, number 9. Right away, I see this point, which is cluing me to a pyramid, but I'm gonna double check. Opposite that point I see a base shape right here. Okay. So that's telling me that this is a pyramid. There's one base and there's a point opposite the base. For our height of the prism, it's that perpendicular height connecting the base to the point. So let's go ahead and plug this in. We need to find the area of our base. This time we don't have a square base, we have a triangle base with the dimensions 3 and 4. For the area of a triangle, we're doing 3 times 4. Don't forget, triangles divide by 2 for area. So 3 times 4 is 12. 12 divided by 2 is 6. So the area of our base is 6. For our volume, we take the area of our base, which is 6, times the height of our prism, which is 3, and then we are dividing the whole thing by 3, because that is the formula. Area of the base times the height divided by 3. 6 times 3 is 18. 18 divided by 3 is 6. So 6 inches cubed. All right, one more. Looking at this shape, I see on the bottom here a triangle, and this time the opposite of that triangle isn't really a point. I see another triangle up here. So it does look a little bit different than the one that we saw on the front, because there it was, one was kind of front and back. This one, it's top and bottom, okay? And then the length that is connecting these two is that height right there. So since we have two parallel and congruent bases, this is a prism. Remember, for prisms, it's area of the base times the height. We're not dividing by 3. So our base shape is a triangle. The triangle has 5, 8, and this side is 11, but the sides that connect at the 90-degree angle are 5 and 8. So for the area of our base, we're doing 5 times 8. It's a triangle, so divide by 2. 5 times 8 is 40. So 40 divided by 2 is 20. So for our volume, we're going to do our area of our base, which is 20, times the height of the prism, which is 3, which gives us a total volume of 60 centimeters cubed. We don't need to divide by 3 because it's not a pyramid.